So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir and today we will going to learn theta notation. So we have learned big O notation, omega notation. Now what actually theta notation means? Informally we can say that it is used to represent the tightest bound of a function. Let me take an example to show you what actually it means. So here the worst case time complexity of this algorithm will be order of n, and the best case time complexity of this algorithm will be also n, omega of n. So we can say that the time complexity of this algorithm is bounded between upper bound and lower bound. Therefore we can say that it is a theta of n. So let's take a look at the definition. Now this is the definition, that it says f of n is equals to theta of g of n if and only if f of n is less than equals to c1 into g of n and f2 is greater than equals to c2 into g of n. For or n should be greater than n naught, such that there exist three positive constants c1 and c2 both should be greater than 0 and n naught should be greater than 1. Now this is the graph it look like. We can see that f of n is bounded by two functions c into g of n and c1 into g of n. So when both the function c2 into g of n and c1 into g of n are approximately same, then we can say that f of n is equals to theta into theta of g of n. Now let's solve some problem based on theta notation. Now here the f of n is n plus 5 and g of n is n. Now according to the definition, f of n should be less than equals to c1 into g of n. Now let's substitute the value in this equation. We get n plus 5 is less than equals to c1 into n. Now we have seen how to solve this question. Therefore we get c1 as 2 and n naught as 5. Now the second equation is f of n should be greater than equals to c2 into g of n. Now let's substitute the values. N plus 5 should be greater than equals to c2 into g of n. Now by solving this equation we get c2 as 1 and n naught as 1. If we do intersection of these two values, we get the common value n naught as, because we know that n naught, it is a starting value of n. So when n naught equals to 1, it means the value of n is starting from n and goes to, let's say, k. Similarly, when n naught is equals to 5, it means the starting value is 5 and it goes to k. So the common term between these is 5, because here there will exist a 5, so the common term will be 5 only. So n naught is 5 and c1 value is 2 and c2 value is 1. Now we got these three values, so we can say that f of n is equals to theta of g of n. Now let's solve the next question. Let's substitute in the equation f of n is less than equals to c into c1 into g of n. We get n plus 5 is less than equals to c1 into n minus 5. So we get n naught as 15 and c1 as 2. Let's substitute in the second equation. F of n is greater than equals to c2 into g of n. By substituting the values we get n plus 5 is greater than or equals to C2 into n minus 5. So we get n naught as 1 and C2 as 1. So the common between 15 and 1 is 15. So C1 value is 2, C2 value is 1 and n naught value is 15. So we can say that f of n is equals to theta of g of n. This equation is used to solve in big O notation, and this is used to solve in omega. Now I have shown you how to solve this equation and this equation. When this equation satisfied and get these two values C1 and n naught, similarly for omega C2 and n naught, we says that the big O notation satisfied. Similarly for omega, when these two terms are satisfied, we can say that f of n is equals to theta into g of n. Now let's solve the next question. F of n is equals to n square and g of n is equals to n square plus n plus 5. By substituting the values in first equation, we get n naught as 1, C1 as 1. Similarly, we will put in second equation, we get n naught as 3 and C2 as 1 by 2. So the common between these two terms 1 and 3 is 3. So we get C1 as 1, C2 as 1 by 2 and n naught as 3. So we can say that f of n is equals to theta of g of n. Let's solve the next question. Here f of n is n square and g of n is n. Let's substitute in first equation. F of n is less than equals to C1 into g of n. N square is less than equals to C1 into n. Now I have shown you when there is a difference of function, then big O will never satisfy. Similarly, omega will also never satisfy. So this is not possible. Therefore, we can say that f of n is not equals to theta of g of n. When there is a function difference, theta, omega, nor big O will satisfy. This will be our last question. F of n is equals to n square and g of n is equals to n square. By substituting in the first equation, we get n square is less than equals to c into n square. Here n naught is 1 and c1 is 1. Similarly, substituting in second equation, we get n square is greater than equals to c2 into n square. Here also n naught is 1 and c2 is 1. Common between this is 1 only. So we get these three terms. So we can say that f of n is equals to theta of g of n. Now between two functions f of n and g of n, if the dominating term is common, then we can say that theta function is always possible. Now let me write this important term. Now I hope you get this theta notation. In the next lecture, we will see small o and small omega function. Thank you.